In 10 minutes, I'm going to try to not only show you the power and beauty of the Pythagoras Theorem, but also show you it so that with confidence you can use it in your exams and in life. This is the Pythagorean Theorem, and I've even given it its own cool font. Let's get started. You can only use the theorem in a right-angled triangle. How do I know if a triangle is right-angled? You'll always know because there'll be a little box in the corner, like so. This is now the most important stage. We need to label our triangle. The two short sides, which are always the two sides next to the little box. See the little box there? It's next to this side and it's next to this side. So these two sides we can label A and B. It doesn't actually matter which one we call A and B, as long as we label them A and B. There's A and there's B. We always have to label the side opposite the little box, which is also always the longest side, C. That is called the hypotenuse. You may have heard of that, the hypotenuse. Hypotenuse. That's the side C. What is the formula? Pythagoras, by the way, was a guy in ancient Greece about 2,500 years ago. He didn't actually invent it, but he popularized it. He spread it around. It actually was the Babylonians who invented this. It goes back a long, long way. The theorem says, if we get the area of this square here, if we make a square on the side of this triangle here, on the A side, and we get a square on B side, those two squares, the area of those two squares, if you add them up, they equal the area of the square on C side. How would we write that using maths? You'd write that by saying the area of A square, which is the same thing as saying A squared. Squared is just A times by A, and if that's A, and the sides are equal because it's a square, so that's A times by A is A squared, which is the area of A square. A square plus B square equals C square, and that's always true in a right-angled triangle. A squared plus B squared equals C squared, and that actually is the Pythagorean theorem. We're kind of done. We just need to practice and bed it in so much that you completely get it and you're really confident in actually using it if it came up. A squared plus B squared equals C squared. Let's take this actual example here. In this triangle, if A was 3, if A was 3 and B was 4, what would C be? Well, the area of this square would be 3 times by 3, which is 3 squared, which is 9. So this square would be area 9. B squared would be 4 times by 4, which is 16. So B squared would be 16. 9 plus 16, because remember these two squares add up to C's square. 9 plus 16 is 25. So 25 equals C squared. How do we get from the square to the root of the square, as in the number which produced it? Because C can't be 25. That's way too long. That doesn't make sense. The whole area is 25, but we just want one of its sides, not the whole square. You need to do the square root, which looks like that. That's the last hard bit of Pythagoras, doing the square root. The square root of 25 is 5. So if C squared equals 25, C equals 5. In other words, this side here is 5, and we're done. Let's do another example though. just to bed it in. Here's another right angled triangle. Now I'll flip it just to confuse you. Doesn't matter which direction it is. It's still Pythagoras because it's got the little right angle, the little box. And it also doesn't matter if the numbers are decimals. Sometimes you'll get a perfect number, as we did in the previous example. You'll get a 5. In this case, we'll get a decimal, but still Pythagoras works. There we go. We've got that side as being 4.2 and this side as being 8.3. Well, in the last example, I did 3 squared plus 4 squared equals the big side squared. So how about I just do 8.3 squared plus 4.2 squared equals the other side squared? No. We rushed it. We didn't label our sides. It went a bit wrong. Let's label our sides. There's the little box. So there's the two sides. So this must be A or B. Doesn't matter. If that's A, that's going to be B. The side opposite the box, over here, the longest side, the hypotenuse, must be C. So it's the 8.3 that is C, and the 4.2, which is A or B. So we can't add them. The formula is not C squared plus B squared equals A squared. It makes a big difference which one you have. It's actually this square plus this square, which equals this big square. How would we work it out? Well, if A squared, which is this square, and B squared, which is this square, add up to C squared, which is this square, we can also say that if we get that big square and take away this small square here, we'll be left with the area of this square here, A squared. Let's do that then. 8.3 squared, which is the area of the big square, take away the area of B squared, so take away B squared, that looks like an equals, so let's just use my marker. Take away B squared, which is 4.2 squared, equals A squared. There are many different ways of writing that. I could have used the formula straight as I did before. So I could have written like this: A squared plus 4.2 squared equals 8.3 squared. It's the exact same thing. I've just moved the 4.2 to the other side. I've picked it up and minused it so it goes to this other side. I just find students remember it more if there's all the numbers are on one side. That's why I tend to think about it as the big square, take away the other square, equals one of the smaller squares. In this case then, 8.3 squared, take away 4.2 squared. 8.3 squared in the calculator is 68.89. Take away 4.2 squared, which is 17.64, equals 51.25. So I can write 51.25 equals A squared. 51.25 equals A squared. There we go. We've got A. Not quite. We've got the area of A's square. What's the last step for finding what A, which is this length across here, is? That's what the question was originally. Find A. Yes, we do the square root of 51.25. In my calculator, I just have to press this, and I get 7.16, let's say. So rounding it out, A is 7.16. I can't really fit it anywhere. Let's just write it here. A equals 7.16 centimeters. There we are. That is the Pythagorean theorem. and some ways of using it.